So we're going to go to our next presenter, which is Devin Grobert. He is a biologist senior for the City of Austin's Water Quality Production Lands. He is also a PhD candidate in plant ecology at UT Austin.
Thanks, guys. Today I'm going to talk to you about woody cover response to thinning and prescribed burning in Central Texas savannas. So here's the study system. Water quality protection lands are 34,000 acres protected south and southwest of Austin by your municipal water utility. The light blue stuff is conservation easements. The medium blue is owned outright by the city. And my job is to implement the long-term management plan on that. It's about 12,000 acres. 5,000 of that is woodland, mostly occupied by golden cheek warbler. The other 7,000 are managed savannas in burn units. And the yellow lines on this map show permanent vegetation transect monitoring sites that comprise the data set I'm going to present the analysis on today. And our mandate is to optimize the quality and quantity of water entering the Barton Springs segment of the Edwards Aquifer, here highlighted in purple. So we interpret these as disturbance-dependent savannas all over temperate, subtropical, and tropical parts of the world. You can see native flora that is full sun dependent, highly diverse herbaceous layer that occurs in a climatic envelope that can and does also support closed canopy woodlands. So in the picture on the upper right, you can see in the background there's extensive forest with pockets of grassland embedded, and then in the foreground extensive grassland with pockets of woodland embedded. This is the same climate, same soil type. It's thought to be a product of adaptive strategies among plants, specifically whether they generate tissues that promote the spread of surface fires, thus gaining a competitive advantage over fire-sensitive species that would otherwise be superior light competitors, or suppress the spread of surface fires. A couple of examples would be grasses that draw moisture back into the crown and roots after senescence of the foliage, leaving a flammable fuel bed to promote the spread of surface fire. Or as we see in like live oak and Ashe juniper, when their foliage senesces, it creates a pretty dense fuel bed that suppresses the spread of surface fire. So I'm offering this up as a framework to interpret how it could be that we have Ashe juniper as a keystone species in the woodlands, very urgent conservation mandates, endemic species as we've discussed in other talks today, and it's also driving woody plant encroachment into grasslands. And it's kind of important native part of both of these kind of systems. So why does a water utility care about this kind of stuff? Well, a founding concept in our land management planning documents is this inverse relationship between woody cover and water yield that's been referenced several times today. Here's a meta-analysis. This is from 2001. They compiled 250 different studies worldwide. This regression line on the top, the solid regression line, shows much higher annual evapotranspiration in forest than the dashed regression line for grasslands. Note the relationship totally breaks down under about 500 millimeters of rainfall per year. That was 20 years ago. We've learned a lot about how these systems work in the interim. Here's another meta-analysis from 2022. This one compiles 251 studies from around the world, finding with decreases in woody plants, you see increases in net precipitation and soil moisture. That means the amount of water that reaches the land surface. Increases in tree level water use after thinning, with decreases in stand level transpiration. As we saw in that previous plot, that's contingent on mean annual rainfall. Thinning intensity of 50% is the threshold at or over which hydrologic processes are significantly affected. And a duration of thinning effect is between about 2.6 and 8.6 years. So that disturbance-dependent savanna has disturbance as an endogenous part of the biology, a product of adaptive plant strategies. And that repeated disturbance return interval is also necessary for this hydrologic benefit that we're interested in if we're interested in improving groundwater recharge. A couple of studies from the Edwards Plateau calibrate this for our region. I've chosen these studies because they attempt to estimate the entire water budget, that is, account for all the water that enters the system as precip and partition it. This Dugas et al., somebody else mentioned this study earlier today. We see both of these studies actually follow the same design. Two adjacent basins are instrumented. One of them is treated, the other one's a control. And they instrument it before treatment and after. So you have before, after, control, and treatment study design. The untreated has higher evapotranspiration for a period of about 3 years. Then it goes away in the 4th year. Note this one, Banta and Slattery, these are both from the Eastern Edwards Plateau. This one from 2010 in Bexar County. Note the biggest part of this water budget, the green part of the pie chart, is evapotranspiration. It decreases modestly in the treatment watershed before, that's pre-treatment to after treatment. It goes from 78 to 74. But look at the change in groundwater recharge. It goes from 17% to 24%. So it's a modest proportion of the overall water budget, but it's a 40% increase in groundwater recharge. So here's our data from our transects on the WQPL. This is the long-term effect of the combined treatment regime. So this data set has about 50 prescribed burns, 50 thinning treatments, 90 rest periods contained here. Each of the points in red is the initial observation. Those are mostly around 2006. The points in blue are the final observation. Those are around 2021. So over this 15-year period, this land management regime that had roughly 100 interventions, half thinning and half burning, we saw no significant change in woody plant cover over that 15-year period. We think woody cover would have encroached significantly, up to about 75 or 80% during that period. So it was a maintenance treatment regime. We maintained savanna structure. So, how did this happen? If we did all this juniper thinning, if as we just learned, juniper is relatively fire sensitive compared to the other native woody plants, was there some turnover in species composition that led to the same overall total woody cover in the system? The answer is no. The plot on the upper left, this is juniper hovering about 10 or 12% throughout the study period. No significant difference. Cedar elm, marginally significant difference, marginally significant trend, about 3% to 4% over that 15-year period. Live oak is flat, 17.5%, and this combined total of 7 most common species of resprouting shrubs, it's hovering around 7% throughout the study period. So we want to learn more. We want to get a refined understanding of what is the discrete impact of individual classes of treatments. And so the rest of the plots for this study are going to be those short duration response to treatment. So here we have the kind of plot I'm going to use for the rest of this study shows pre-treatment woody cover on the x-axis, post-treatment woody cover on the y-axis. So a point anywhere on this plot is going to show you the change in the response variable over the monitoring interval. The monitoring interval is mean of 1.9 years. We try to measure a range of vegetation characteristics on our transects 6 months before planned treatment, 18 months after, and do the same on a control site nearby with similar properties. So the dashed line is the one-to-one line. So if you see a point directly on that line, it means no change over the monitoring interval of 2 years. Here's all of our treatments in the data set. The green circles are rest periods, no treatment is applied. Blue squares are cool season fires. Red squares are growing season fires. The yellow plus signs are juniper thinning treatments. Some of those they're almost all anything 4-inch diameter at breast height and under. A few of them go up to 6, very few of them go up to 8-inch. And then the pink triangles are mixed brush shredding treatments. And so here we have a line in green that's for just rest. That's a regression line for the rest treatment. So the fact that it's a little above the dashed one-to-one line indicates a predicted or an estimated increase in woody plant cover from a rest period. And so here's a regression line for each of these treatment classes. Excuse me. So note that we have the A group. That means the rest in green is not significantly different from the blue, which is cool season fire, but they are both significantly different from either class of thinning or growing season fire. So the text on the left will show you we expect an 8 or 9% decrease in woody plant cover from either a growing season prescribed fire or a thinning project. and we expect a 3.5% increase from a rest treatment, which means no treatment really, a rest period of about 2 years. If you divide that by the duration of the monitoring interval in years, you get an annualized woody plant encroachment rate of 1.8%. And then that lets us do a return interval equation for each of these treatment classes. So in the case of growing season fire, we've measured a 9% decrease in woody plant cover as the response variable in this case. We infer another 3.5% that we didn't measure, but we expect woody plant encroachment to have been going on during that monitoring interval. We divide it by the annual woody plant encroachment rate, and we estimate a 7-year return interval for that treatment. So if we want to maintain current woody plant cover levels, we should repeat the growing season fire treatment every 7 years. If we're taking longer than 7 years, we're slowing but not halting woody plant encroachment. If we're doing less than 7-year fire return interval for growing season fire, we're gradually reversing the woody plant encroachment trajectory. If we do the equation for cool season fire, we estimate about a 2-year fire return interval for maintenance. And that's why the blue line, the regression line for cool season fire, is pretty much right on that 1-to-1 line, indicating no change over the 2-year monitoring interval. So I have these kind of plots and these kind of data for all woody species that occur in the system. We don't have time for all that, but here's Ashe Juniper. Same pattern. Cool season fire is not significantly different from rest, but they are significantly different from growing season fire or either class of thinning treatment. Note that the predicted response from, or the estimated response from all woody species combined was a 3.5% increase over the monitoring interval. Ashe Juniper, it's 4.6% per increase per monitoring interval. So how can that be? How can it be more than the total combined woody plant cover? The answer is Juniper is driving encroachment into grasslands at a rate of about 3.5% per rest interval, and it's overtopping other woody species by an additional 1.1% per rest interval. So here it is for different size classes of Juniper. Note, for the smallest size class, those less than 5 feet tall, all these treatments, cool season fire, growing season fire, either type of thinning, is significantly different from rest. This is the number of plants per acre, estimated change. As soon as we get to the 5 to 10 foot class, either cool season or growing season fire are no longer significantly different from rest. These are prescribed fires where grass carries the flame front. We don't have crown fires as Charlotte was talking about. I have these data for all these other species that occur. This table shows everything that has more than 1% cover in the system. So we have a lot of Mahonia and Bumilla languinosa. Those are both about 1/2 or 2/3 of a percent. Some patterns here, with rest periods, the other tree species other than Ashe Juniper are still increasing. Resprouting shrubs are still increasing. Growing season fire, everything's decreasing. Almost all of those are significantly different from rest. So that's a good treatment to reduce woody plant cover. Cool season fire, they're all really close to zero. Hardly anything is significant in there except for this group of the combined effect response variable of the 7 most common resprouting shrubs. And then thinning, everything's positive here. So if you thin Juniper out of the system, of course, that gives a big competitive advantage to all the other woody species in the system. So it's not really effective, or it's marginally effective for reducing woody plant cover, but it's really could be a benefit to improving woody plant evenness, the evenness part of the diversity equation. I've got a YouTube talk, webinar on how land management interventions affect, water yield and how landscape physiognomy responds to land management. So please check it out if you're interested in that. A lot of wisdom on that topic in the room today, so I'd love to hear from you. Here's my email, and I think we have a couple minutes for questions. Yeah, the question is, how do the prescribed burns affect the grass assemblage? I haven't finished the analysis on that. I could say it certainly decreases the abundance of KR blue stem when it is highly abundant, but it doesn't matter what season. That's what this data set shows. You know, anecdotally, I could say there's a lot more forbs on prescribed burn units, a lot more blooming going on after a burn in any season, but it doesn't seem to last very long. It's just if you remove the thatch from grasses, there's a short-term benefit, competitive benefit for forbs and for flowering. But I'm working on that now. That's part of my dissertation research, and I'm hoping to be able to present that in the next few months. Yeah, I showed the results from 2 classes of thinning treatments. So shredding here means mixed brush shredding. So that's any non-oak woody species. And then thinning is just targeting juniper thinning. So usually the thinning is chainsaw crews, and shredding is a skid steer with a masticator attachment. Yeah, so I mean, the first thing is to make the structure, the habitat structure on the landscape, more conducive to carrying surface fires. So if we have like a very low diversity juniper break with some small, remnant, little blue stem, side oats, things like that, and the juniper all uniformly small diameter, we think it's the product of pretty recent encroachment. So we can specifically target juniper in those instances. It's also, I think this was practiced more earlier in our program's history than it has recently, mainly because I've been going around saying this for about 15 years and nobody's corrected me, but if you see it differently, please tell me. Juniper and elbowbush are the only 2 woody species that are native that won't resprout. So it's kind of like an easy target. If you're going to do top disturbance to reduce woody plant cover, that's when it makes sense to go after, because everything else will grow back readily from the roots. Yeah, I mean, if you look at the herbaceous layer under ash juniper versus the herbaceous layer under any other woody plant, there is a significant difference in richness. I don't have that plot today. I'll present on the herbaceous response in the coming months. But yeah, the juniper encroached areas have much lower herbaceous diversity compared to live oak or especially persimmon. Persimmon plays really well with herbaceous. No, I mean, my expectation, grasslands have much higher soil bulk density than woodlands. And as Pedro reported, and we've seen, actually, there was a study, I forget the guy's name, in 2005 on the WQPL, much higher infiltration rates at the soil surface under juniper compared to on grasslands, right? So I think that's different than deep drainage, which is what we're going for. I think we see in those couple of eco-hydro studies where they instrument ET do the right adequate thinning intensity to get a hydrologic response, we should expect juniper understories to have higher soil moisture holding capacity and to take more moisture, as Pedro described. That also could just be keeping moisture in the rooting zone of plants and amplifying transpiration and hydrologic cycling.